Dann danke euch. Gleich mal vorweg, ich komme aus Österreich, deswegen, wenn ich Deutsch spreche, verfalle ich oft in Dialekt, darum spreche ich gleich in Englisch, dann überspringen wir das gleich. Also, I'm Michael in that regard, thanks for that, one of the founders of Bosch Trustworthy collaboration services, and our mission is pretty simple to explain. We want to have software collaboration between companies and organizations without distrust, without silos, and without friction in that regard. And just a quick to my background, I have 10 years now since I started my professional career in automotive software development, so deeply embedded, very strict development efforts. And throughout the years, I've on several occasions tried to implement new development approaches, state-of-the-art tooling, new collaboration models with our customers and suppliers. And everybody that works in a similar company to Bosch or in a similar domain knows that's not so easy and especially not so fast. And today, to explain what we do in this venture, a startup within Bosch, I've brought with me a case study of 3 organizations, of 3 companies that want to work together on software, announce their partnership, but somehow they can't. They can't effectively and closely work together on software assets. And this is not because of missing technology, no. We found that it's everything around, everything that's not technology. It's about the risk of losing IP or companies having the assumption that they are losing IP and therefore also revenue. About data privacy. Where do I work together? Do I trust this environment? Who hosts this? Who is the administrator of that? And then, on top of everything else, then there comes the compliancy regulations, antitrust regulations, etc., etc. So technology is not the point. And that was a major hurdle for our 3 companies now that want to work together but can't, or only with with high pain and high stakes in that regard that they have to solve via contracts and NDAs. And we from Bosch Trustworthy Collaboration Services, we thought, can't we do this differently? And for that, for our 3 companies now, I want you to imagine that there's a virtual space where those 3 companies can work together as transparent as they would within a joint venture, but without founding one. So that they can cooperate common IT systems without a single administrator, that they can co-compute on the data that I said before can be their crown jewels, that can be data that they don't want to share with their partners, with their competitors, or whomever. And third one, and the most important one, that they can co-create value for their customers as a global optimum, and not just for themselves. And let's start with the first phase, cooperation. If I want to cooperate together on software, I need a common environment somehow. And today, we have a problem. There will be always a single administrator. Somebody has to be responsible to set it up and to administer. And we go a bit of a different route. We say, in this setting, we introduce a technology process that we call trusted multi-party operator. And this trusted multi-party operator takes over the administrative role of a system under control. So many things now to digest. A system under control can be anything, any IT system that offers an API that is secured. So authenticated, authorized, and has a role concept behind it. That can be any SaaS service that we know, so the GitHubs, GitLabs, Artifactories of this world, any self-development or self-developed applications, Kubernetes clusters, or complete cloud instances, a GCP instance, an AWS instance, whatever. We all saw that already. And the TMO, how we call it, has 3 major components. One is the operator core that abstracts the working of this system as an administrator. So everything is abstracted to the TMO and works together by a shared consent mechanism. And that's the second part. This trusted multi-party, that's where the multi-party comes from, steers the system as a single administrator, but the TMO self is steered by only the collaborating parties. And if you remember, I said we have 3 companies We don't need a fourth one. This is the fourth one. That's the technology process behind it, where also the consents and the administrative part of this IT system is handled together, but only by the companies that are collaborating. And now you may be asking, okay, how do I trust this thing? Yeah, that's just another process. We are using confidential computing for that, to enable that. So the TMO itself, you can look up the source code for that. You see how that works out, so you can see into the processes and how the consents mechanism works, but only with confidential computing you can then also attest it at any time. So you have a verifiable state at any time, and everybody can verify that on their own. So it's not, again, a centralized thing. Everybody can do this by themselves. So now to our three parties. When we bring that up, they work now together with the TMO. So the big box in the middle, that's now our TMO approach. And the TMO takes the administrative role over the system under control in that regard. And as I said, that can be anything from a Kubernetes cluster to an existing system. And they do this with infrastructure as code in that regard, or consents mechanisms, pull requests, whatever. However, the parties want to do this. And the most important thing, shared governance, always in that regard. Verifiable state, shared governance. And therefore, I click through it to save on the time in that regard, because I want to come to the case study itself. For each of the three layers, we have 4 key pillars. One pillar, that's the tamper-proof verifiable state. Confidential computing allows us to do that. Decentralized for every party to verify the state of the system. Shared control from the get-go, so there is no central administrator. I can't call somebody to change something. It has to be done via consents for the collaborating parties themselves to gain the trust in that regard. Already told the admin part, and the fourth thing that's also important, wherever I want to host this, I don't care. Because of confidential computing, even the infrastructure provider or the one who hosts this environment can't look into it by the technology itself. It's not possible. So therefore, if a customer tells me, or one of the 3 parties tells me, I want to host this myself, go for it. The only thing you need to make sure that confidential computing is enabled in your hardware. That's the only thing. So now we established a common system for the 3 parties. And for our sakes, let's imagine that's a CI system. In our case, for this POC, it was Tecton. Let's imagine now I want to work on data, source code, etc., that I don't want to share to my other parties. Not because the developers don't want to, but because I can't, of compliance issues, the IP risk, etc., that I said in the first place. How do I do that? How can I still enable computation on this very information? That's firstly done. Kubernetes. Yeah, we've heard it now several times today. We are also using Kubernetes clusters for that, but confidential Kubernetes cluster. They are also running, like the TMO, in a confidential computing cluster. So they are also as secured against the infrastructure provider and against tampering as the TMO itself. And that brings with us a very important thing also in my industry, in the automotive industry, a trace. From the get-go, I have a tamper-proof trace that I can check from any part that went into what was processed, how it was processed, how the pipeline was built, that I have a verifiable state and an audit log in that regard. I always know what happened in that. Everything that is brought into this Kubernetes cluster, as I said, there's no single admin, so no one can do this on themselves. The pipelines, the automation environments, the test environments, they are done or aligned by the parties themselves, by the 3 organizations that I said before, via this consents mechanism of the TMO. And only once they align on that, then it is rolled into the Kubernetes cluster, not before. That's also a trust-enhancing mechanism, that nothing runs in my shared space without my knowledge. And already said that the automation itself, there can be anything that can run in a Kubernetes cluster. So build systems, test systems, debugging systems, simultaneous debugging systems, AI assistants that help us out in that regard. Everything in this confidential Kubernetes cluster, and you can imagine that as a black box. So you can't take something in and nothing can get out. Only the thing you define per consent, what happens on the information that they provide into this black box, can happen, nothing else, and nothing gets out. Come to that in a minute, why that's important. So again, 4 key principles in that regard. Data and code that I share now together with my other partners is always secured and protected. Not just protected by just not being able to look at it, but also from an IP ownership and data ownership perspective. The workflows and workloads that I run on the common data or the common information pool then is always run before via the consent mechanism, so everybody approved what's happening on that. The logging and attestation, so at any time I can prove the state is in its system and in its state that I expect it to be. And very important, last pillar again, tool-based access. That means the builds, the LLMs, the test systems that run inside the cluster, they have access to everything. They are not restricted by who brought something in. Everything that runs in the cluster has access to the full context, but only to this context. And now, for our 3 companies, now they said, okay, I have now the possibility to share a common space, a common IT system. Great. Then we established a confidential Kubernetes cluster to run our common workloads on that. Also good. But what helps me that to create my end value? So a common CI system where I can develop together and create the binaries for my customers faster than before. And that comes now to the co-create part, because a development environment does not consist of a singular Kubernetes cluster itself or a singular system. In our case, we needed a binary storage because somehow the things that I produce together in my common space need to be stored somewhere for everybody to access. I wanted to have a common SCM system where I store my pipeline definitions, so the automation parts before. Also that should be common. And the development clusters themselves. And that's exactly what we call, so to say, the ecosystem approach. I glue together existing systems, new systems, with the TMO, and allow a trusted access between them. And that allows me, as I already said, for our 3 companies now, to run an LLM only for the collaborative context, without access to outside of this context, only within the collaboration part and the collaborative workloads. So they can optimize the LLM and train it really only on data they want and specific to their needs, nothing else. I already told about the virtual joint venture. So it should feel for the developers like they are in a joint venture, like they work together with their partners from the other companies as they would sit beside them, but without the hassle of setting up the contracts for that and setting up the legal setup for that, because the system itself, the technology itself, provides this abstraction already for them. And that allows then the seamless interaction with the systems under control. Last sentence to that, the developers themselves, they will never see the TMO system. They shouldn't. They only should feel the impact on the system under control themselves. So they should have, suddenly I have access. I can do the pipeline run. I can do the test. I see the test results. But they never interacted with the administration part before. That is done by very few administrators to keep it low profile in that regard. So the impact for the developers should be minimum to none. And again, 4 pillars also for that. The joint creation happens in this trusted collaboration space. As you saw before, the collaboration space itself, that's a combination of many systems, existing ones, new ones. The legal requirements to set up something like that, the virtual joint venture, that's handled by the technology itself, not by any long-going contract discussions. For our 3 companies in this example, they did it in a classic way before. It took 4 years for them to set up the contracts before they did one deployment together. Cost optimizations, why that? I don't need to replicate every system and every environment in every company again. I can share them now. I centralize them with the trust that confidential computing brings in. And last but not least, it feels unified, but still the operations are separated. So everything I don't want to collaborate on and everything I still want to keep with me, within me, that can stay with me. I don't need to bring anything that I don't want into this collaboration. So at a glance, I won't talk again in detail about that, but we have those 3 layers in our platform in that regard, and the 3 innovations in that regard that we bring together for our 3 companies now. And how does this look like in exact? You see it here. Everybody who saw a Tecton dashboard before knows that. And what do we enable with that? We don't have the time to look into that, so come to us afterwards if you want to see it running in that regard. So an invitation to that. But what do? We have then a single source of truth. Not, oh, works on my machine. No, it works in our collaborative system. And if it runs there, then my tests are through. Then my check is done that it's done. We allow policy-based access in that regard. So everything that I said before, the TMO approach, the consent mechanism, that's logged, that's attestated, and it's policy-driven. So everybody knows who had access at which time, what was accessed, what was brought into, but without having access to the sources themselves. Only the tools inside our space have full access, not the parties themselves. Everybody speaks of AI. Also, we included an AI agent in that regard, which you would see if you are at Microsoft Ignite, because there we are introducing exactly that with our technology partner Intel and Microsoft, how this looks like for our 3 companies to have a trusted AI agent that helps me finding out bugs and fixing them without me having access to the information source code data of my partners. The 4th thing in that regard is the contracting thing. I said before, our 3 parties in our classic approach needed 4 years to set up the contracts. In this regard, I start with a slim contract, and every time I do another initiative, how we called it, so starting a new administrative change, that's then my contract, because it's verifiable, reproducible. So I start with a small contract and extend it throughout my development, and not I have to have it ready at the start of the development. Real-time cross-company debugging is one thing. Also, feel free to ask us about that, what we do there. Simultaneous debugging in that regard. Cross-company dashboard, so at any time I want to see the status of my project, of my delivery, without having access to the systems or to the data information of my partners, but still the overall environment and the trusted access. That's one of the key parts. Everything that runs in my trusted Kubernetes-Cluster can have access to the full context, but still keeping IP protected to each party, keeping the IP ownership and data ownership to each party, and still enable a joint venture like collaboration. And with that, I already said, I would like to invite you to discussions afterwards. And I would like to understand maybe your domains, your challenges also in that regard, because we have an automotive focus. That's very strict in that regard. But how about finance? How about other manufacturing parts? So I would really like to get in touch with you, and I'm open for questions, German or English, whatever you like in that regard. Thank you.
So, questions from the audience? Would you go over to the microphone, because that makes it easier for people participating in the stream? That's very nice.
My question is, how do the users, the developers, then access these systems, and how are these client machines in the end then trusted?
That's the point. So if we are using the confidential Kubernetes cluster, then we are using Kubernetes role-based access in that regard, ensured by confidential computing. And if we are speaking of, let's say, existing systems like a GitHub or GitLab, then we are using their onboard mechanisms. Because that's the interesting part when we talk with customers in that regard. Do we really need to bring the GitHubs or Artifactories of this world also in a trusted or confidential computing environment? No, we are already trusting them today. So there we are using the onboard mechanisms that those platforms bring with them.
Okay, now you talked about external systems.
Yeah.
I meant the client machines, like I as a developer need to...
If we are speaking of a common system like GitHub, like that, you don't need anything in addition. You as a client machine, you don't feel it in that way. You don't need that. That's only for the collaborative parts, which you would interact with via the native environments. So you wouldn't feel that this is a confidential cluster, a confidential environment.
Okay.
Yeah.
And if I pull out data? Sorry for asking so many questions.
Please. If it's allowed by a policy that was done before, then yes. Otherwise not. That's the point. So everything is strictly secured unless we three, for example, if we work together, we define a policy that, okay, this part is allowed to be pulled out for you. Then you can. Okay. Same thing goes for debugging. Same thing goes for testing.
So it's safeguarded by these policies then?
Yeah.
Okay, thank you.
Yes, hi. I would also be interested in more technical details later.
Sure.
My question is, does it extend to collaboration tools as well? So ticketing system, chat, and so on.
So we haven't implemented that yet for example, a ticketing system. But yes, so as I said, the approach is as generic as any system that exposes a secured API can be included in that regard. Yeah. So short answer, yes, we didn't do it yet.
Right. Yeah, I've got a question. So you mentioned policy as code.
Yeah.
Are you using like the native Kubernetes OPA layer for policy as code, or are you using something else?
So without saying something stupid, currently we're using Caverno, Sebastian, no? Yeah, we're using Caverno, a policy engine in that regard.
And I assume that the confidential hardware that it needs to run on is either AMD or Intel that supports crypto.
Now I say, of course, with Intel it's best, but it also runs on other CPU vendors or even GPUs.
As long as it supports the crypto.
Confidential computing has to be secured or allowed, but that's the only requirement that we bring. So if you want to host it in any public cloud provider, any of them, even the Chinese ones, are offering that. And you can also do it on an OpenShift or self-hosted.
Yeah. Okay, thanks.
Yeah, sure.
Two maybe small questions. One is you said they can decide what's in and out.
Yeah.
So question is, what's the ratio across their development process? So you said that's one part, and the other part is you said only stuff which gets consensus goes in. So how do you ensure that all those contract theoretical discussions to get something new in is not blocking? So you have something today. How quick do they agree on getting new things in?
So maybe start with the second question. They agree with an iterative process. Yeah, can't tell too many details, but we can talk afterwards. It's an iterative process, like we know it from today's coding. If you would do it with your team directly, so it's something similar. And once you reached milestone or whatnot, then you do say, yeah, consensus reached. Now apply it, please, to my system, because it has to be verifiable and administered by all of them. And the first one, so say the traction, if I got that right?
Is it a ratio, let's say, how much they keep separate and how much they have shared?
I think there's no single answer to that, because it depends on the use case itself. So it fully depends on how complex the use case is and how much foreground IP I'm already developing together. So if you are nearly open source, you might not need us. If you are more in a more restrictive part, where we have classic binary shipping, and interface-based integration, oh yes, then it becomes very interesting because suddenly you don't do your tests or your integration on binaries, you do it directly on source without having the access to the source. So it depends, I would say. It can go from to.
Okay, thank you.
Yeah.
Then time for last question. Okay. If not, I think you're still around here.
I'm around, yes.
They can catch you. Then thanks a lot, Michael.
Thank you.